This conference will now be recorded.
Hi everyone, good morning. Able to hear me?
Yes.
Okay, perfect. Okay, so as part of the demo, we talked about two stages will be there when you go for Azure Data Factory projects. The first stage is data ingestion. We are going to dump the data from various data sources and we are going to keep it a single location, or we can say it is a centralized location. So in order to extract the data, we are going to use Azure Data Factory, and in order to load the data into destination, we are going to use Azure Data Factory. So we are extracting and loading, and in the next second stage, we are going to talk about data transformation. The second stage, we are going to talk about data transformation. So in order to go for data transformation, again, we are going to use the same Azure Data Factory. We have a feasibility to handle all this stuff at single place. So in the second stage, your data source is Azure Data Lake Storage Gen 2. 99% is data sources Azure Data Lake Storage Gen 2. And your destination is also same in the second stage also. So here we are going to talk about completely data transformation. We are going to transform the data from one form to another format. And let's talk about how, like, I wanted to talk a little more in detail about this data storages. So we can call this when the moment we start taking data from the business, the particular business system, we can call it as a OLTP system. So wherever we are going to have a business data, various starting stage, that particular system we can call it as a OLTP system. So OLTP system is going to have a data. OLTP system is going to have a data. And even wherever you go here, this place or any place, we are going to have a data only. So data is not going to be readable and data is not going to be understandable. So that is about this data. You can see here the difference between the data on top of your business data. We are trying to get information on top of your business data. We are trying to get the information. So who is going to get the information means the BI team, the downstream of our system. Downstream of our system is responsible to get the information. So to get the meaningful information, we need to provide cleansed data to them. We need to provide cleansed data. So cleansed data is going to be much more visibility for visualizations. So how data is going to be there when you have a starting of your system, you're extracting here. You just imagine this is a OLTP system. If it is a OLTP system, you're going to have a completely business data. OLTP system, we can say there is a business data. How they are going to bring the data into this particular system is not our job. Our job is how we can bring the data from here. So from this part it is going to be happen. So data is going to be there in the form of raw. Raw data will be there. It is not in shaped. So how we can say that is a raw data? We are going to come across with examples. So when you have a raw data, definitely there will be unprocessed facts. Unprocessed facts will be there to represent your data, figures, symbols, or observations. All those things we can call them as a data. We are going to collect this system, OLTP system is going to collect all these things. And even in the various forms, like you'll be having a text data or images, audios, videos, all together we can call it as a data, which is not going to have a meaning. So we need to get information on top of the data. So simply for time being, I just wanted to say the data is going to be there in the form of rows and columns. Okay, generic example we can say, but basically you will be having images, you will be having videos, you will be having audios or raw text data. So many things we are going to have it. Okay, so there will be no context for that particular data. We need to bring it. So example for this is collection of numbers representing temperatures recorded over a month. I'm just recording each and every day what is the temperature. You're collecting that, how much temperature is on each and every day. So that is the data. So first day some like first day some temperature, second day some temperature, like this. If we collect for 1 month, if we collect for 1 month, if I wanted to get which day is highest temperature or which day is lowest temperature, if I required from that particular 1 month temperatures, 1 month temperatures is a data, and getting topmost temperature and bottommost temperature, that is the information. So from this data only we need to get it. Let's say even if you say trends, each and every day if you show the trends in a line chart, this is the information. So data, from data only we are going to get the information. That means wherever there is a reporting team, for them we are responsible to provide the data. I'm just saying collecting data on every day temperature, but basically we need to do many things, which is not just taking and giving. We need to go and do some shaping, we need to go and apply some transformations. So that is going to be happen as part of this. Okay, so example for data is collecting each and every day temperatures for a month, and if you wanted to get insights on top of that particular data, then we are going to say that is a information. So I'm just giving the differences between the OLTP system and this. And information is a result of processing and organizing data to give a meaning and context. So we are going to get clear picture on it if you have a information. So this is about the reporting. We are not going to be part of it, but just I'm just giving an idea how it is going to be there. So it is the interpretation or analysis of the provides insights, knowledge and understanding. Okay, so example, you just see the example, then you can understand. If the recorded temperatures are analyzed and presented as a average monthly temperatures, and every day you are collecting for months, and if you wanted to see each and every month how much average temperature, then definitely we need to go for information only. So on top of the data we can get average monthly temperature or highest temperature or lowest temperature we can get, or we can get temperature trends across each and every month also. So this is about reporting, this is about information. This information is going to get from the data. So what is the use of this? Why we are taking a data and why we are going for information? So information is the target for business users. Information is the target. The intention of this information to take the decision making against your business. If you wanted to grow in your business, definitely we need to have a information. So how we are going to get the information from the data? We don't give directly raw data. We are going to do the transformation. So when data is moving from this place to reporting, when the data is moving from this place to reporting, reporting is there in this particular place. So while traveling data from source to destination, that is going to be done many things. So that part we are going to be there. Okay, so data serves as the foundation for generating information. So that means data is a foundation for your generating information. So information is essential for decision making, problem solving, and understanding various phenomena. So if you don't have the information, then we cannot understand the business. So to understand the business 100%, we required information. So to get the better information, we need to provide better cleanse the data from the data. From the raw data to, we need to provide cleanse the data to the downstream system. So previously, before coming to this Azure Data Factory, even I wanted to talk about little more in detail about OLTP system and WLAP system. So presently also is available this OLTP system and WLAP system is also available. So how it is going to be there, I'll talk about it. When I say OLTP system, it is completely related to the business system. So where we are going to run the business or where we are going to have all business data at one place. So the name itself is saying that online transaction processing system. Online transactional processing system, we can say. These two systems will be there to store the data. The OLTP system, the name itself saying that we are keeping daily transaction data. So when you order a product, in Amazon or Flipkart, the order details is going to store at one place. So that particular place we can say it is a OLTP system. But OLTP system may be database, the OLTP system may be even file system or anything. So wherever you have a business related data very starting, that particular system we can say it is a OLTP system. So what is the use of this OLTP system? The OLTP system is going to do real time processing. Real time transactions is going to be handled by using this. So the design itself is going to have a normalization. The design itself is going to maintain normalization. Normalization means the system will not allow any duplicates. I wanted to capture day-to-day temperature as I said. If I wanted to bring it on every day, I cannot maintain here. This system is not designed for maintaining historical data. So when you order a product, later some point of time, you may cancel few of the items, or you may change your address, or you may do any changes. So in order to capture historical data, this particular system is not possible or is not designed for maintaining historical data. So when it is not maintaining historical data, then definitely that is, as a data engineer, that is our responsibility to maintain historical data. So how we are going to maintain historical data, where exactly we can do it, that I'll talk about it. So this particular system is going to have a completely business data. So what is happening at this point of time, all those details are going to be there as part of this OLTP system. So that is what I'm saying here. We're going to have a real-time processing here. And normalized data structure means we cannot allow or we don't allow any duplicated records into this particular system. So why we are not going to allow this particular system is not allowing duplicate records is to run the business we should not allow duplicate records. It kills the performance of business. So if you don't run faster business, if it is waiting for your transaction to commit it, it's going to impact the business. Because of that reason, this system is not going to handle any duplicated data. It is completely unique data. So how they are going to maintain unique data is with hundreds of tables. So hundreds of tables is going to talk about normalized data structure. So it is going to minimize the redundancy. Okay, so and of course the consistency of the data is also will be there. And in this particular system, we can provide the DML operations only. So like insertion, update, and delete. So these three operations only we are going to apply in this particular system. And concurrent access, that means at one shot multiple people can access it. multiple users or multiple customers can make the transactions. So if multiple customers making transactions means it is allowing to access with multiple people. And you will be having primary key based indexing in this particular system is because to maintain the relationship, as I said, we are going to have a normalized structure, right? That means making a relationship between one table to another table to maintain normalization. So why it is not allowing duplicates is because you will be having relationships like this. So there will be hundreds of tables and you will be having primary key and foreign key to make the relationship. So if you don't have a relationship between the tables, then we cannot maintain unique data. So this particular system is specifically designed for running the business. And right after completion of the day, what they're going to do is from this OLTP system, they're going to dump the data into file system. So at some point of time, they're going to dump the data into file system. So this file, whatever the data is there at this point of time here, the same data is going to be available in this particular place. So what happens? They don't give a direct access for us. We cannot access directly your OLTP system, because if you're trying to read the data from here and some customer is trying to make a transaction, so both are going to be overlap. So this will impact your business. We should not hold this. We should enter this one. So to avoid this, what they're going to do is they're going to dump the data into the file format. This file will be handed over to us. This file will be handed over to the ADF or any ETL tool in the market. So we are going to read the data from this particular file system, not directly from the OLTP system. So since we are having a business data in this particular file also, we used to call this also as a OLTP system. So it's a, like, we can say, a view of your overlap system or OLAP system. So that is how it is going to be there.
Oh, sorry,
And
sorry,
the
sir. I just have a doubt. Does this mean it gives only structured data?
whatever it is, even basically previously we used to talk about the structured data, but when it comes to now, currently in the current market, we are having a semi-structured data and unstructured data also.
My question is, so does the OLTP give only structured data? Because we are using it as like business data only, no? So we'll get only structured data, right? Mostly.
No, we have a even NoSQL databases, right? So those
Uh,
also will be used for doing having some business kind of data. Let's say you have a game. Okay, so you're playing the game. How this log is going to be stored?
okay, okay.
So
Yeah,
that is also business related data.
yeah, exactly. Thank you.
Okay, so JSON format, they're going to have it. API data, or we used to call it as a JSON format. So those kind of data, we can say it is a semi-structured data. So that data also we are going to take it from them only. So various examples are there for this OLTP system. All customer relationship, CRM applications comes into the OLTP systems, e-commerce, banking systems, inventory, so point of sale systems, all those things example for your OLTP system. So simply to run your business, definitely you need to have a OLTP system only. The design itself is going to say to keep only unique data. And then next is OLAP system. So this is the place where we are going to work. We are going to take it as a destination. Okay, so for time being, you just think it as a OLAP system which is used to have a historical data. So there will be many things. We have a Azure data warehouse to have a historical data, and previously we used to have a databases itself is going to have a OLAP system characteristics. We used to maintain all those things. So the design is going to talk about it. So here we are going to have a different kind of design when you compare with the OLTP system. So the design will allow to handle historical data. So this particular system is going to be having even aggregated data also. We are going to keep it in this particular place. So this system is specifically designed for analytical processing. If I wanted to analyze my business, then definitely we need to have a OLAP system. The reason is, if I wanted to compare my current month sales with the last month sales, or I wanted to compare, now July is there in the 2023, I wanted to compare last year July, how last year is there and how it is there. Is that going up or going down? To compare that, definitely we need to have a historical data. So historical data is going to be possible to keep as part of this OLAP system. And we are going to have a denormalized data structure. So denormalized data structure means the number of tables will be less when you compare with your OLTP system, and the design itself is going to allow you duplicates. When the data is getting duplicated, we can say it is a denormalization. So that kind of features we are having as part of this OLAP system. And multidimensional analysis we are having as part of this OLAP system. We can slice and dice the data, we can drill up and we can drill down for doing analysis as part of this if you have OLAP system. And data consolidation, we can have it as an integrated data source as part of this OLAP system. Your OLTP system is distributed. You may have a data in a SQL server, or you may have data in a even like JSON format or any other format, or you may have a data in the file system. So that means your business system was distributed, whereas this OLAP system is going to be there only one system. It's integrated. It's a integrated system. So how we are going to make this integrate is by using the Azure Data Factory. We can integrate it. We can take the data from here, we can take the data from here, we can take the data from here, and we can integrate and we can keep at one place. So if anyone wants to do any analysis, we don't require to go and bring the data from the different places. It's very difficult also for downstream system. So if we can give all this data at a single place, the downstream system is going to take data from directly from this particular system itself. So that is what it is saying here. And we are going to have a aggregated data here. Every second you're collecting the transactions. If you take Amazon, we are going to get the transactions each and every second or each and every minute, and from the different locations, from the different customers. So once you capture transaction details at the time, we are not going to analyze the data by time. We don't do that. So in order to do by month wise, I wanted to see the comparisons. I don't need the data at the time. So time level data you're going to have as part of this business system. But when it comes to the OLAP system, the business users are not interested to see the data at the time level. Business users are not interested to see the data at date level also. They wanted to see the data in all the reports. They decided to see the data at month level. So the granularity is different. The storage granularity in the business system is time, and the storage granularity in the destination in the data warehouse is at month. So we are going to do the transformation here. We are going to apply summarization as part of this Azure Data Factory, and we are going to store summarized data in the OLAP system. So what happens is the size of the data is going to be reduced, and instead of having data at the time level, we are going to have a data at month level. So that improves the performance. So this is very important key characteristic as part of any ETL project in the market. Is everyone clear as of now with OLTP system and OLAP system, how it is going to be there?
Yes.
Yeah. And then I'm going to talk about what are the difference between on-premise system and cloud system. So why we need to go for cloud? We already having so many projects are already existed with traditional ETL tools. Traditional ETL tools already existed. We have a SSIS from Microsoft, SQL Server Integration Services, and we have a Informatica Power Center. We have a data stage. There are many ETL tools in the market. So this all these tools are on-premise tools. So not only this, when I'm running the business, definitely I need a data. I used to have a data when I run the business. If you take a Flipkart or Amazon, when they run the business, definitely they're going to collect all the customer details, all order details, they're going to collect it. So we need to store this data. For storage, definitely one system is required. Why you are storing it? To understand the business. To run your business is one type of storage. To understand the business is another storage. That is what I told you. To run the business, OLTP system. To analyze the business, we need to go for OLAP system. So all this storage is also is on-premise. Your OLTP system is on-premise, and your data warehouse, that means OLAP system, is also a on-premise system. And whatever you're doing processing, the processing systems also on-premise. So everything was on-premise. So if everything is on-premise means everything you need to take care about it. If I wanted to increase the capacity, if I wanted to increase the compute power, I need to order it. If I wanted to upgrade it, I need to take care of it. If something happened, installation, setup, power system, cooling, security, everything that you need to take care. So run and maintenance is very, very huge when you compare with cloud systems. The reason why people are traveling towards to the cloud is because to reduce the cost. That is the only main reason. And of course, performance of the services also we are having it. So performance when you compare with on-premise systems with cloud systems, there is a drastical changes. So I have seen some of the jobs used to run for days also with SSIS. So we have some monthly jobs. When we run that monthly job, it will go for 2 days, 3 days also. But when you go for cloud systems or when you go for cloud services, we are having a different kind of processing systems, different kind of processing approach that improves performance. So that is also one of the reason to go for Azure cloud systems, or we can say cloud systems. So that is what I'm just saying here. On-premise refers to the traditional approach of hosting and managing IT infrastructures. So you are responsible for hosting and you are responsible for managing also. So not only infrastructure and software within the organizations is your own on your own physical premises or data centers. So that is your responsibility. So in order to do this, organization has to purchase, maintain, and operate. So everything they're going to take care about it. So you will be having own servers, you will be having store devices, networking equipment, software applications, everything that you are going to take care. So simple we can say it is your own house. You have to build it, you have to do everything for your side. But if you can go for rent, once our work is completed from that particular area, we can vacate from that particular place. So monthly we are going to pay the rent. If I get a transfer from one location to another location, I cannot stay here if it is not my home. If I am a tenant, definitely I am going to vacate it. I'll take my I'll take my what we can say comfortability. But if it is my own house, then definitely I have to stay. Okay, so that is going to be one of the problem, right? We cannot buy a house each and every location when we transfer from one location to another location. So that is what it is on premise. If I buy a compute power, if I'm not using that further days, it's waste. Okay, and cooling system, networking, everything we need to take care. So instead of concentrating on the business, you need to concentrate on the infrastructure and run and maintenance. So that impacts the business. So very starting that is fine, but now last 10 years onwards we are not having. I mean to say this problem getting we got a solution for this kind of situations, and we are responsible for maintaining infrastructure, hardware provisioning, software installation, updates, securities, backups. So every day I wanted to take a backup of the database. You just imagine if that particular premises is collapsed for some reason. There may be a disaster or there may be a power failure or anything. It was collapsed. So if the system collapsed, then you cannot run the business. So that is one of the bigger problem if you go for on-premise. You're going to lose your data. If you lose the data, then running a business is very difficult. And data is very, very important. So because of that reason, previously even with on-premise, they used to store the data in a different locations. They used to have a data centers, private data centers we used to have, and they used to take a different places. But you need to pay a lot of amount. So to avoid this, market is observed. This is the place where having a feasibility to do the marketing, and cloud vendors came into the picture. So cloud computing, what happens if I use the cloud computing? So this is your own house and this is your rented house. So rented house, you can stay how much time you want to stay and then you can vacate. So that is what we are going to have features here when you go for cloud computing. So cloud computing means instead of taking care yourself, someone is going to come and someone is going to take care about it. I wanted to buy a compute power. You don't worry about it. Someone is going to give it to you on the fly. You don't require to go physically. You don't require to collect physically. Okay. So if you wanted to take some service, you don't require to go there. They will give a service and you can use the service. Once your work is done, then you can leave the particular service. So that is what the cloud computing. So cloud computing is a model where computing resources and services are delivered. We are going to take the compute resources, that means compute power, and services. There are a few services I will talk about what is compute power and what is a service. All these are going to be delivered through your internet only. You can access them. I wanted to buy a virtual machine with Windows operating system, with SQL Server, buy a virtual machine. So through internet only we can buy it. So the way your system is going to work, in the same way it is going to work. So within just minutes we are going to have it. But if you wanted to bring the same kind of a system in on-premise, it's going to take a month also. It's very difficult. So many approvals are required and many teams are going to participate to handle it. But when you go for cloud computing, so few administrators are responsible to buy this. Once they have a approval, then they're going to do it. They're going to uh, set up everything it just in minutes. So instead of maintaining their own infrastructure, organizations can access and utilize virtualized computing resources. You can take the VMs. Apart from this, some people, if you are interested, you can take a compute resource, or if you wanted to take a service, you can take a service on demand. ADF is a service, is not a compute power, that comes under service. You can take this service on demand. So that means if I use for 1 hour, I'm going to pay for 1 hour only. I don't pay for entire day. But if you go for SSIS or Informatica, you are going to have a license per year. Okay, if you use it or don't use it, they never care. They will take a license cost. But when it comes to the ADF, it is a service. Not only this, there are many services we are going to have on demand. If you use for 1 minute, you can pay for 1 minute. So that is what it is. You can utilize virtualized computing resources and services on demand. And these services include servers you can take, storages we can take, databases, networking, software, and various other services also we can take it from the cloud computing. So we are going to talk about Azure Data Factory. Azure Data Factory is a service from the Microsoft. You need to store the data. Storage is required. That storage is also one of the service from the cloud computing. So Azure Data Bricks also is a service. So most of the times, as we are going to work as a data engineers, we are going to handle most of the times the services only. So what are the benefits if you go for here is the scalability. If I go for on-premise, if there is a only one person to complete your work, one person is going to work. But if you go for cloud, on the fly, for just next 1 week, I wanted to do work with 10 persons. You can assign 10 persons to complete your work. That means you're increasing the scale. How many days? Just 1 week. After 1 week, I'm going to make it down. Okay, so I'm working for one of the area of project in my company. We have a development database, we have a QA database, and we have a fraud database. For development and all, we are not using this even, and we are directly going for QA. For development and all, what happens is we will be having very less volume of data, and this is not possible to validate the data. This is just for designing. This is for just developing the ADF pipeline. We used to call it as a pipeline. Okay, we'll talk about all those details. At the time of development, what we are going to do is we are going to use the development database as a data source. Development database as a data source. And within the same place, we are having staging database and main database, development server and QA server, prod server. Three servers are there, and different databases within the same place. So what happens is, if I wanted to read the data from the business system to this particular system, it is taking very longer time. Of course, at the time of development, we are not going to load the data. So to test my data, what I have to do is, I have to run my pipeline from the QA environment. So when I'm trying to run the QA environment, what it is doing is, it is not even loading the data into this particular database. So I'm trying to identify what is the reason it is taking too much longer time. Even if I write a simple select statement, select top 100 from a table name, it is not even getting. Basically, it is very simple code. If I run the same query on the production side, it is getting in seconds. But the same query, when I try to execute here, it is not getting executed. Is because the scale is very less. Because testing is not going to be happen every day. Whenever there is a changes, because it was already existed project, whenever there is a changes in the pipelines, that time only we are going to validate against the testing database. So if you are not doing testing, that means you are not using this particular resource. If you are not using this resource, why you need higher compute power? Why you need 4 people? Go with only one person. Just keep only one person. So whenever testing is required, you are going to increase the compute. Okay, so initially we will be having 10 DTUs or 10 missions. You just imagine. With 10 missions, it's very highly impossible to run a single this particular statement also, is because we are having more volume of data. So to run this one successfully, we need to do this. We have to do 200 DTUs. Okay. So when the moment I increased up to 200 DTUs, that means you are changing the configuration, the scalability. You're increasing or decreasing. Once my testing is done, if I have a 200 persons to do my work, definitely I need to pay for 200 persons. I cannot say I will pay only for 10 people. So as many number of persons or as many number of DTUs are there, for that many number of DTUs you need to pay it. So once my work is done, completing my work is very important. Okay, so if you can do it faster, you can do your analysis faster. If you do analysis faster, you can grow in the business. So that feasibility is there here. And if you do the same thing in on-premise, it's not even possible. Every day you cannot do it. Every week also you cannot do it. You have to fix some compute power if it is on-premise. So whatever you use, for that only we are going to pay. So that kind of feasibility we are having as part of this cloud systems. So that is a scalability. I experienced this when I'm working. So when I checked with the team told all these details. Okay. So here we are responsible. They have a given responsibility to increase the compute power, and whoever increase the compute power, that person is responsible to downgrade also. So when there is a demand, you can go up. When there is no demand, you can come down. So that feasibility is known as a scalability. And cost effective. I already told you, even this example talks about that. So if there is a 10 DTUs, you are going to pay for 10 DTUs. If there is a 200 DTUs, you need to pay for 200 DTUs. So that is a cost effective. Whatever you use, for that only we are going to pay it. We don't require to invest infrastructure. So they are going to take care about it. Okay, so run and maintenance, taking backups, all those things are going to be taken care by cloud computing. So if a disaster happen, even you can have a data in 3 different places. If this is collapsed, you can have a data in 2 different places. And even if this is both are collapsed at one shot, still you are going to have this data. So I'll talk about that. So those kind of feasibilities also we are going to have it here. So cost effective cloud services operate on pay as you go model. Whatever you use, pay for that only. Allowing organizations to pay only for resources they actually use. So whatever you use it, pay for that. So pay as you go. So this feature eliminates the need of upfront infrastructure. So as I said, if I wanted to increase the compute power, you need to buy infrastructure. We don't require it. So it eliminates upfront infrastructure investments and reduces ongoing maintenance and operational costs. These are all talking about cost efficiency. And global accessibility. You can access from anywhere. You can access from anywhere if you have internet and if you have access. Okay, so that is what it is, say global accessibility. And agility and speed. Cloud services enable organizations to rapidly provision and deploy resources, applications, services, and reducing the time required for infrastructure setup and software deployment. So, in order to do the deployment or in order to increase compute power or anything, it is going to take less time only. But if you do the same thing in on-premise, is going to take months. So to set up itself is going to take longer time. So that we can avoid if you go for cloud computing. And reliability and resilience. We can maintain the redundancy here. So cloud providers typically offer robust infrastructure with built-in redundancies. Redundancies is important. If you store at one place, the same data is going to be 3 times is going to be replicated. So max 6 times we are going to replicate it. So where exactly we can go for max 6 times? Where exactly we can have it by default 3 times and 3 places. So I'll show you how it is going to be there, and I'm going to talk about more in detail about this redundancy. So there are many services which are managed by cloud vendors only. There are many services. If you take a Azure Data Factory, you are not installing, you are not doing anything for this. We don't require any operating system also to handle this Azure Data Factory. If I wanted to work with SSIS or if you wanted to work with Informatica, definitely you need to have a operating system. But when it comes to the managed services, all managed services are not required any operating system. We don't we don't know which operating system they use behind the scene. We are just taking a service which is managed by cloud vendors. So cloud providers offers a wide range of managed services such as databases. We don't require to install the database. We don't require to update anything. Automatically it is going to be upgraded. So databases is a managed service from the cloud. And machine learning is a managed service. We don't require to install. There are many analytics services, that is Azure Data Factory, Azure Databricks, streaming analytics, analysis services. All those comes under analytics services. And security services also we are having many things as a managed services. And monitoring services also we are having. So there are many services which are going to be managed by Microsoft or any cloud vendor we can say. And there are few services, as I said, virtual machines, right? If we have a virtual machine, if you wanted to install any software, then if you install SSIS in this inside, then we can say that is we are going to maintain this particular service. But virtual machine is maintained by someone else. I mean to say infrastructure. We are not going to, they're not going to come inside the virtual machine. They're going to give a compute power, how much RAM is required, how much CPU is required, so how much throughput is required. So all those things is given by cloud vendors. So these services reduce the burden on organizations. IT teams as the cloud provider handles the management and maintenance of the tasks. So all those things are going to be reduced if you go for cloud computing. So there are many features to go for cloud computing. Okay. So I'm stopping here, and tomorrow I'm going to take you through who are all the cloud vendors are there, what are the different types of services we're having. If possible, I'm going to show you how this cloud, I mean to say, since we're talking about Microsoft Azure data engineering, so how exactly we are going to have a services, how we can access the services from the Microsoft Azure, we are going to talk in the next session. So I'm stopping here. If you have any question, you can ask me.
Can you please share us the notes, sir? Like
Yeah,
so,
we will share.
yeah,
We will share it.
You'll share it in what, like WhatsApp, or you'll share the link?
The team will share
Yeah, okay.
maybe in WhatsApp. So
Yeah,
they will share once you registered, they're going to share the details to you.
yeah, sure. Thank you.
Yeah. Anyone else? Any question? So this is just I'm giving the overview how it is going to be there on premise and how exactly cloud system and why we need to go for the cloud system. So these are all the basic information. So nowhere we are going to face this kind of questions at the time of working, but knowledge is important. Why we are going for Azure Data Factory is important. So to know it, we need to know about what is the cloud computing and what is your on-premise. So as I said, Azure Data Factory is not required any operating system. Your Azure SQL database is not required any operating system. And even there is a storage service that also is not required any operating system. So we are going to use as a service and we are going to complete our work. So we'll talk more in detail going forward. Okay, then thank you for joining and we'll see you on tomorrow.
Thank you.
Thank you.